Another thing that you run into when you're dealing with microservices is how you actually understand the dependency graph and how you do troubleshooting. So let's say you have a graph of multiple services. A talks to B, B talks to C and D, D talks to E and F. So you've got this graph and you have a request that comes into your system and it has to flow through that entire graph to actually get all of the operations done. Well, all you can see at first glance is that the request took a certain number of seconds to complete. But is that A's responsibility? Is it B's responsibility? Is it D's responsibility? You don't really know. So Google created a technique called distributed tracing and wrote about it in a paper on a system that they created called Dapper. So what distributed tracing allows you to do is to assign an ID to a request when it comes in. And then that ID flows with the request in headers as it transfers through the system. So you're now able to attach start and stop events to each of the communication points, and that allows you to figure out A, what is the dependency graph for a given request, and B, how does each of those links in the graph contribute to the overall latency. Twitter actually implemented the Dapper paper in an open source project called Zipkin, and what we're going to do in this talk is we're going to learn how to use Zipkin and then components from Spring Cloud Sleuth to build microservices and then actually trace the dependencies and look at the latency characteristics of each of the links in the graph.